Right, let's take a wee look at the next part of the similarity journey, talking about similar areas. So, in the previous lesson, we spoke about shapes being similar and the fact that all their lengths are multiplied by the exact same scale factor. That's what makes it into the bigger shape, but with the same dimensions, the same angles on the inside. When we look at areas, though, it's not as straightforward. So let's consider a rectangle. So if I consider a rectangle that measures 6 centimeters by 3 centimeters, the area of that obviously is going to be 18 square centimeters. If I was to multiply my sides to make a similar rectangle, so say I was to apply a scale factor of 2 to that, it would give me a length of 12 centimeters and a breadth of 6 centimeters. If I was to go and work out the area of that, the area would be 12 times 6, which would be 72 square centimeters. That's not double the 18. Okay? So when you multiply your sides, your normal one-dimensional lengths by a scale factor, yeah, that increases it. But if you were to multiply obviously 18 by 2, we should be getting 36. It should be 72 square centimeters we get as the area for the bigger rectangle. So what you need to do is you need to take account of when you're dealing with area, you're dealing with 2 dimensions this time. So that's what the V power 2 of the area units means. The V power 2 means that you're multiplying 2 dimensions together. So when you get your area, what you need to do is take your scale factor and then square it. So if I was dealing with a times 2 for the lengths, I would need to square that to get an area scale factor. So that would mean multiplying by 4. So therefore it would be 18 multiplied by 4, which would give me 72. So when we deal with areas, all we do is get the scale factor the way we did before, but this time all we need to do is just square it. So let's look at some examples on that then. So two semicircular objects are mathematically similar. The larger semicircle has a radius of 14 metres and an area of 308 metres squared, whilst the smaller one has a radius of 7 metres. Find the area of the smaller semicircle. Okay? So let's forget the fact that we're dealing with semicircles, because I know you could go ahead and just do a half pi r squared for this. That's there just to prove that it works out. Okay? So let's see what's happening here. Now, the new shape is the one that has the question mark. That's where we want to work out the area. So that's the new, and this one here is the old. So start off with your normal linear scale factor. So scale factor is going to be new over old. So that's just going to be 7 over 14, which gives us a half. So the scale factor is going to be a half. Because I'm dealing with areas, what I need to then do is go ahead and square my scale factor. So I'll call it ASF, area scale factor. And all I need to do here is just square that first of all. So a half squared gives me a quarter. And then that's what I'm going to then multiply my area of 308 square metres by. So I would work out that the area is going to be a quarter times 308. So basically I'm just finding a quarter of 308, which will give me 77. So it'll be 77 metres squared. Okay? And yes, let's just go ahead and test that out to make sure it works. Okay? So the area of the semicircle, I can say the area is going to be a half pi r squared So it's going to be 1/2 times pi times 7 squared. Pop that into your calculator. 1/2 times pi times 7 squared gives us, it comes up as 76.969 and so on, which rounds to give you 77. Okay? Obviously, you don't need to do that for the semicircle. That's me just showing you that this similar way works. Let's look at example 4. It says 2 skull-shaped fridge magnets are mathematically similar. So there's the clue. There it's telling you this is what we do. We're dealing with similarity. The small magnet has a height of 6 centimeters and an area of 22.5 square centimeters. The large magnet has a height of 15 centimeters, and I want to find the area of the large magnet. Okay? So the thing we want is on the bigger shape. So this is the new shape, and this is the old shape. So I can say that my scale factor, my normal scale factor, look at the lines. You always take your scale factor from the lines. It's going to be new over old. So that's going to be 15 over 6, which cancels down to give me 5 over 2. Because I'm now dealing with area, what I need to do first of all is square my scale factor. So if I square that, I can say that my area scale factor is going to be 25 quarters. And then I can go ahead and multiply to find out the area of the large skull. So I can say that the area is going to be 25 quarters times 22.5. So go to your calculator, 22.5 multiplied by 25 quarters, which gives me 140.625 centimeters squared. And that's how easy it is. That's us working with similar areas.